Hello and welcome. This is Team Laser, and we will be reviewing Chapter 11. So we begin our discussion on process monitoring by defining what it is. This kind of monitoring is essentially a collection of methods and techniques that is applied on data produced by executed business processes to gain further insights on process performance and conformance to any relative business norms, policies, or regulations. So why exactly do we do it? Well, we want to essentially get a very good picture of what our current process performance is across the board. We analyze all the processes, especially the ones that are deemed as underperforming, to get a very good picture or an idea of why they are underperforming. What are the root causes of the underperformance? And it can also be applied to overperformance, as this kind of deviation or variability can have some negative consequences if left unchecked. So we essentially want to see if there are any exceptions, such as any bottlenecks occurring that would lead to additional wasted time or resources, or any deviations to the norm. As I mentioned previously, a process is usually designed in a way that it will execute and produce the desired results or the expected results, the best possible results. So any deviations of variability, such as shortcuts, could be a net positive, but could also negatively affect something else. And in order to do monitoring, we do need event logs, which we will touch upon or on later on. And in essence, the monitoring does produce various output artifacts that can be helpful for any kind of analyses that might be needed and for general stakeholder awareness. So, process monitoring techniques can be broken down into one of two groups. Either offline or online process monitoring. The first one, offline, deals with historic processes, essentially processes that have happened in the past and those that we want to gain a better insight once they have already occurred. Um, we can dictate different timeframes as well, such as yesterday, a couple days, a week, months, or even years long timeframes for the processes. Alternatively, the online monitoring occurs with processes that are currently running. Those are in progress, and both of these techniques require the use of event logs as inputs. Um, but they can also be broken down into two other different types of classifications, either statistics based or model based. The first one being statistical and performance measures being the bread and butter. This gives way to descriptive statistics such as mean, medians, and averages of certain measures that we want to record, such as resource utilization or waste or average cycle times, things like that. And we can take those figures and essentially visualize them with certain tools and techniques to create graphical depictions, uh, and in essence produce things known as performance dashboards, which we will touch on later. And the other is model based. Again, we will touch on this later, but a quick synopsis is that uh, these are essentially just the mapping of processes with various tools and techniques, and that they also require event logs to produce them. Uh, but they can also be manually constructed and automated as well. So, speaking of performance dashboards, these are graphical depictions of one or multiple business process performance measures or characteristics. These are based on and categorized on the purpose and audience that they are geared towards. And there are three main types. The first one, operational, the second, tactical, and the other, strategic. The first type of dashboards that we will be discussing are operational dashboards. These dashboards generally display the performance of current or recent processes, and in this context, they're called cases and they allow for short-term work planning. The target audience tends to be the actual performers of the processes, such as employees, their direct managers or operational managers, and the actual owners of the processes. And this, again, just gives way to general oversight of the process. Typical measures, again, are generally those that are involving work in progress. So how many cases are open currently? How much work is there left to be done? How much work has been done are examples of this. Additionally, like what are those that are overdue? That would probably be configured in a way that the dashboard would alert employees of overdue items. And these are sometimes defined at the task or the resource level. So it can be broken down. For example, that pie chart on the right, it can show how many items employee A has left to do, how much they have accomplished that day, or how much a whole team has to do. The next dashboards we want to look at are tactical dashboards. These dashboards typically display the performance of processes over a long period of time. This can include months, quarters, years, and the main goal is to gather evidence of undesirable performance variations and possible causes of these variations. Again, this can include long-term bottlenecks, process deviations, and the sources of these deviations. The target audience are process owners, functional / oversight managers, and process analysts, or those business analysts tasked with finding out what's wrong with processes, how to improve them, and how to gain insights from them. And some typical measures displayed include numbers related to the completed processes and or descriptive statistics. Again, medians, modes, means. And some examples below are the number of completed cases, cycle times of processes, any waiting times that happen between, um, defect rates that can happen when the process runs, and even resource utilization. And a very common depiction is seen here on the right in the form of histograms. The third and final dashboard type are strategic dashboards. These types of dashboards provide a high-level view of the performance of groups of processes along many performance dimensions, groupings, or even business areas. And they are generally constructed by aggregating performance measures in one of two ways. The first being by aggregating performance measures for an individual process into one performance measure for an entire groups of processes in a process architecture. So that sounds like a mouthful. So an example to illustrate this would be uh, using resource utilization. It's a category of efficiency, but it's just one measure of efficiency. And to allocate a resource utilization figure, we would probably give out an average for process A, process B, and process C. All three would have their own average. And then once we give them proper weights, then we can mesh them together to come up with one whole resource utilization for one group of processes. And a group can be like the North American factory resource utilization compared to a different factory across the globe. And then the other is of more high level, but more slightly more complex aggregation, which involves multiple performance measures related to the same performance measure into one measure. And for this, it's instead of being so granular with efficiency, as another example, instead of having numbers for process cycle times and resource utilization, etc., we would find a way to mesh them all together into one single efficiency measure. So we could say the North American factory has an efficiency percentage of 25% or something like that. And these dashboards are mainly targeted towards executive members or managers. They usually want a very quick and easy report or a presentation giving the numbers so they can easily interpret them. So that's why just having one single efficiency measure is probably desired for them, because it gives them a very holistic view of a given area over a period of time, and it even allows them to compare, or at least easily compare that same area to other areas or over other periods of time. So in order to create dashboards, there are many tools and software and even systems that exist that can help us do so. For both operational and tactical dashboards, um, the functionality to create them is already usually included in most off-the-shelf business process management systems platforms. Otherwise, other process-aware info systems uh, platforms have dedicated dashboarding functionality, and these would include Microsoft CRM and ERP vendors such as SAP. Their offerings usually have dashboarding capabilities built in already. Um, but beyond that, if if visualizations are required, there are just dedicated software for that. So like offerings such as Power BI or even Tableau, their advanced visualization capabilities allow for more complex or even detailed dashboards, and those can be used for all three dashboard types. And a very recent trend that's happening right now with dashboard creation is to include machine learning techniques into said visualizations. Um, Again, this is to create a more robust and future-looking uh, visualization, because in the past we relied on historical data. Well, now machine learning can be incorporated to produce more predictive modeling and visualizations as well. So a technique for process performance monitoring is something called process mining. And what this is a family of techniques used to analyze the performance and conformance of a business process or processes based on produced event logs during the execution of these processes. And this technique or techniques complement tactical monitoring dashboarding the best out of the three. And this is because tactical dashboards give a holistic picture of the process health, how it's performing, where it's deviating. Mining can assist in making sure it aligns or can be aligned to a more perfect status. And again, process mining allows for deeper analysis, a granular look at the process level, such as tasks, resources, as who performs the task, and even at what time it occurs in the form of timestamps. And so there are four main mining techniques, which we will be talking about in the rest of the presentation. The first is automated process discovery. The second is conformance checking. The third, performance mining. And the last one is variance analysis. So before moving on to our discussion on the four techniques, we need a baseline understanding of what event logs are. Systems tend to have an explicit process built in that usually dictates the work that a user needs to complete and in what order that needs to be completed in. This not only allows users to have a quote unquote work list or a task list that they're in charge of, but it also hides the complexity of the system as a whole. So they don't have to worry about other people's work or the complexity again of the system. Um, and for that matter, tasks tend to correspond to a step in a process, usually one to one, but that's not always the case. There can exist multiple tasks corresponding to one single quote unquote work item. Users, for example, have three work items under the one task named create campaign template, which is then a part of the larger monthly marketing campaign process. So instead of having just one work item, there can be three, as in log in, create the template, gather images, create the emailing list, etc. And as work progresses or is completed, a system tends to automatically record these events, uh, constantly keeping track of the process from start to finish and usually anything in between. This allows for individuals to have a status report of the process at various different intervals. And most systems tend to record these relevant events in one, usually, sole database in the form of event logs. And these are just a collection of timestamp event records that reveal information about the executed work or the task that is in progress, or any other relevant events for that matter. So again, one example would be that an event log captures the exact time that a user completed the marketing campaign template. So why is this information on event logs relevant? Well, event logs are more or less required in order to run the process mining techniques that we will be discussing next. At a very minimum, these next three event log components are required: an identifier, a case identifier, an event class, and an event timestamp. And to keep things simple, an identifier is just something, a string, a number that helps anyone identify what the case is exactly, or the task at hand. So it could be something like check stock availability. And then event class is just an overarching theme above the identifier. So in this case, it could be something like warehousing. And then event timestamp is just a specific point in time in which that task in the process occurred. And then there are a couple formats that event logs are commonly found in. The first being a CSV file, and then the second an XCS file. Um, the second is preferred mostly because it allows for more complex logging to occur, and it works generally a lot better with the different systems out there. And here in the bottom is an example of the first CSV, and on the right, an example of two different tasks that have occurred in a process under an XES format. So event logs do bring with them their own unique challenges. One of the big ones is conversion to a more user or system friendly format. We kind of touched on this previously, where XES is generally the more desired format, uh, and then thus necessitates CSV files being converted over. This can be a challenge if a user doesn't know how to do it, or it's not an easy task to accomplish. And another one oftentimes is that event log data is not really accessible or easily accessible in the required format, sometimes needing extraction from various different sources, not just one, but sometimes even two or three or four, and then having to compile that data into one log. This can, again, not only be cumbersome, but can create different errors within the data. And then the other four major challenges are correlation, finding the case that an event belongs to. A common one is an attribute being missing, such as the case identifier. That that essentially just leaves a gap in the log where information is missing, and then we can't correlate that to the exact task or event in a log of a process. So again, it just leaves a giant gap. Timestamping. Some systems don't necessarily prioritize logging. This can then produce delays in the logs, errors, and overlapping timestamps to the point that, for example, one event can occur 2 seconds right after another when that's not necessarily true. And then again, that just gives or paints an erroneous picture of what the process actually looks like. Another one that distorts the picture is longevity. Some processes are long running processes, so the logs don't really necessarily know that, so they just capture everything, which includes running processes that are sometimes weeks or months or even years long. So then that can lead people to believe that a process just isn't finishing, when in reality, it's still in process. And then the other one is granularity. Logs can, and oftentimes do, have too much detail to them. And this essentially just necessitates abstraction, fine combing through the detail, all the noise, to find exactly the information you actually need to produce a robust model or a bigger picture of what the process actually looks like. And once event logs have overcome these challenges, we can then produce what are called traces. And these are perfectly ordered sequence of events in a given case. And in this case, events more or less equal to tasks at hand. So again, like creating a campaign, sending an email, that's a task or an event. And events are dictated or noted as symbols or letters. So once the log is cleaned up and traces are established, this is known as a workflow log. And within these logs exist distinct traces, each consisting of a sequence of symbols representing these executed tasks. So below is an example of a log being A, B, C, D, E, F, G, or A, B, G, H, G, A, etc. And you can even put a number in front of it to dictate how many times this log or trace has occurred in one single workflow log.
Let's talk about automatic process discovery. Its people perform tasks and interact with technology, which shows the flow of event logging. And this is easy to understand. For organization, automated process discovery can help them understand the execution process and help them analyze. Then, I will introduce some automatic process discovery techniques, which will be expanded from 4 sections. Look at the right part. I will start with the dependency graph. Dependency graphs, also called directly follow graphs. It shows how process tasks follow each other. It's mutually recorded. For example, picture A is event log and picture B is dependency graph. In picture A, we found that A to B have 6 times and B to A have 2 times. Then go to the picture B. We use arrow to indicate the sequence of process and add number for it. It can help us to understand their relationship, right? The advantage of dependency graph is simplified, not only easy to understand, but also supported by most commercial process mining tools, like Discord, Minute, Process Gold. It is allowed to enhance the readability between the various relationships by changing the color and deepening the line, and I will talk about later. Dependency graph is simple, but when the flow of events become complex, it's very difficult to read. Abstraction operation is another advantage for it. Abstraction means that when we specify the flow of events, we can remove some nodes to get a smaller dependency graph. This helps people to understand. However, when events become more complex, abstraction will not solve the problem, so we can filter to get the simple flowchart. Event filter keep only those events that meet the conditions. It's same for event pair filter. Just change the events to event pair. Trace filter keep trace that meet the condition. In the dependency graph, we can also show the time delay by color coding and thickness coding. In the image on the right, we use different colors to distinguish the switch mapping, and the number above represents the time delay. Finally, in contrast to BPMN, dependency graph cannot easy to distinguish other relationships between the tasks. For example, are 2 tasks parallel? Is it's in a loop. Compared to the dependency graph, the alpha algorithm also simple but limited. It's divided to two stages. The first stage is to understand the sequence of event pair. And the second stage is to confirm the relationship through comparison. In the alpha algorithm, there are four relationships. If and only if some relation x is directly followed by y, then x is followed to y. This is the directly succession. If x follow y and y not follow x, then it's x to y, which is causality. If x to y and y to x, then x is equal to y, which is parallel. Finally, if x not follow y and y not follow x, then x is not equal to y. This is indirectly succession. Now look at the right part. We have 5 diagrams. The diagram A is causality, and diagram B is indirectly succession. The diagram C require B and C are not mutual successor. The diagram D and diagram E are parallel. But alpha algorithm also have limited. First, it's not able to distinguish so-called short loop from the true parallelism. Then the event log must be completed. Finally, it cannot handle noise. Case records are often missing, which can have a huge impact on the alpha algorithm. Fortunately, there are more robust algorithms for automated process discovery, which are listed in the slide. They use event logs to build a dependency graph. After removing some nodes and errors, they apply a set of heuristic rules to discover separation gateways and connection gateways, turning the filtered dependency graph into a BPMN flowchart. They solve the sum limit of the alpha algorithm and make the algorithm more reasonable. They can all be found in AppleMore. We already know many different algorithms. However, different algorithms will be used in different situations. We even will do some change to make the algorithm more reasonable. Then, we conduct quality assessment from the 4 aspects written in the slide. Fitness means that the model can replay every trace in the log. Precision means that any track generated by the process model also appear in the log. If traces that do not exist in the log but appear in the model, it means that inaccurate. Since the log is incomplete, generalization represents how well the process model captures traces that are not present in the log. Complexity means the difficult of understanding the model. For example, when compare models of the same size, one is very simple and the other one is not easy to understand. We already introduced process performance mining. This part will show how to use event log to evaluate process performance in terms of time, cost, quality, and flexibility. Through the time step on the event log, we can make time and size. Event analysis help us understand when and how often different types of events occur. Typically, we build a chart. As shown in the first picture, each point represents a point in time. So, we can quickly get the information we want. When we recorded the start time and end time of the event, there we're able to build a timeline chart. It's more detailed than the dot chart. When we talk about the cost dimension, we will think about direct and indirect cost. The book mentioned a new concept, activity-based costing. We also call it ABC. It wants use task for distributing the indirect cost. ABC will bring benefit, but they also have problem. It needs to know the duration time and when the task start. We usually can see the quality of the product from the execution log. So, looking at the duplicated in the log is a good way to understand the quality. For example, the same issue is being addressed by both the primary and secondary teams, or the issue is repeatedly assigned to the same team. We need to think about some question. How repeated are their product? Do they affect the average cycle time of the process? Using process mining tools can find the same task faster and help us solve the problem posed above. We will use the event log to see how much variation the process allows. Companies need to consider required flexibility and participle flexibility. And in balancing between the two and cause problem with the performance of the process. Being too flexible makes the process less standard, and vice versa. The event log summarizes the basic behavior of the process and is a means of assessing the flexibility of the process. We need to learn to understand whether different number of execution per represents flexibility. For example, to see if employees will only choose a certain execution style because of the budget. On the other hand, we want to consider whether those tasks are all optional. For example, the varying level of difficult result in some tasks not being selected at all.
Next, we'll talk about conformance checking. Conformance checking is concerned with the question whether or not the execution of a process follows predefined rules or constraints. This question can be answered by inspecting the event log. If a particular constraint does not hold, we speak of a violation. In particular, conformance checking is concerned with identifying these violations and making statements about the extent of them altogether. Violations might relate to the three process perspectives of control flow, data, and resources in isolation or in combination. Now for the three recurrent types of control flow constraints. A company might want to define a mandatoriness constraint for a certain task because these tasks are required from a control perspective. An exclusiveness constraint states that two or more tasks cannot co-occur in the same case. This exclusiveness can be checked by searching for traces in which both tasks appear. Then we have an ordering constraint, which states that two tasks must always occur in a given order. Other ways conformance of control can be checked is by unfitting log behavior and additional model behavior. Next, we'll speak about process monitoring. Three families of techniques for conformance checking between an event log and a process model are replay, trace alignment, and behavioral alignment. As you can see, I listed a picture of what process monitoring might look like. And as you can see, the entities all kind of relate to each other based off of the replay, trace alignment, and behavioral alignment. And you can see the arrows correlating the different tasks and how they line up with each other. Now for conformance of data and resources. So far we focused on checking conformance along the control flow perspective by checking occurrence of tasks in their relative order in the event log are consistent with the given process model. But what is equally important is to check conformance along the data and resource perspective of a business process. Participants typically require permission to execute certain tasks. In the reading, it spoke about a project which was valued at around $1 million, and how whoever's working on the project can't just go through implementing the project, but rather they need to get permission from management or a higher power in order to execute it. There are also other instances where the project may not be as high risk or task may not be as high risk, and they may not have to ask permission in order to implement. However, there are times where it may be a high stake case and you have to get permission from the higher ups. Now we'll talk about variant analysis. Variant analysis techniques allow us to analyze differences across subsets of cases in a process. This can be done manually or automatically. From a manual approach, we look to discover process models and compare the two models visually. As for log delta analysis techniques, these techniques take as input two event logs and produce a set of patterns that are common in one model and uncommon in another model, or vice versa. Now I'll talk about process mining in practice. When it comes to process mining in practice, there are two approaches. First is exploratory approach, which is driven by the curiosity to understand how a business process is executed without any specific question at hand. In this approach, we typically start by discovering a process model or by doing conformance checking against an existing model. Next, we have question-driven approach, which is driven by a business problem. For example, we may want to find out why certain insurance claims take too long to be resolved. In this case, we start by identifying and scoping the problem, formulating questions, and then applying process mining techniques to answer these questions. These two approaches are complementary. Oftentimes, we start with an exploratory approach, and as we get a clearer picture of the process and its procedure, we continue the analysis with the concrete business-driven questions in mind. In a question-driven approach, there are typically 5 phases involved: framing the problem, collecting data, analyzing data, interpreting the results, and formulating a process improvement proposal. Just as a quick recap, we discussed 2 families of process monitoring techniques: statistics-based techniques, model-based techniques. We saw 3 types of dashboards: strategic dashboards, tactical dashboards, and operational dashboards. We took a look at process mining techniques, process models, event logs, spoke on several automated process discovery techniques, dependency graphs, all the way to techniques to automatically discover BPMN process models such as split miner. We also spoke on conformance checking, how to check different types of control flow constraints using an event log, how to compare a process model and event log, performance mining techniques, how they allow us to use event logs and process models, variant analysis, dependency graphs, differences between 2 variants of a process, and log delta analysis. And that wraps up our presentation. On behalf of Team Laser, thank you.